This is the second time creating a model of how water flows throughout the Great Lakes. We are to build to scale the geographic locations, lengths, and heights of the lakes and rivers represented. This was done to show the importance of the water flow throughout the lakes and rivers. It also shows the importance of the elevation and river lengths affecting the water flow. We will also see the effects of pollution in this model. This will show us the importance of understanding that wherever pollution begins, it will continue in the water's path.
The model that we created touches on 4 disciplinary core ideas within the next generation science standards. The first of these is ISS220, the roles of water in Earth's surface processes. This concept ties into our model in that fresh water is found in the Great Lakes. The second standard that our model touches on is ISS320, natural resources. The water found in the Great Lakes is a natural resource that humans use, therefore falling into this category. The third disciplinary core idea is ISS3.B, natural hazards. Flooding is considered a natural hazard that we can manage as humans, however, we cannot eliminate this. The final disciplinary core idea that our model touches on is ISS3.C, human impacts on Earth systems. Humans impact the water supply through societal activities such as pollution. This is just one example of how humans can impact our Earth systems.
There were many science practices used in the creation of this model. First and foremost, the most obvious science practice used was using models, because we made a model. We also asked questions and defined problems while creating the model. For example, we had to figure out how to keep the water from leaking as it moved from bowl to bowl through the straws. By analyzing data from geographic maps, we can make our model accurate. Also, by actually running the model, we investigated the process of water flow. Explanations were constructed to explain why what happened had happened, such as concepts of water flow and elevation. Finally, our group communicated information together by discussing with each other throughout this entire process and making these videos.
In this model, you will see patterns across lake elevations in the flow of water. You will see similar elevations between Lake Michigan and Lake Huron. Water is the matter in this model. Notice that the water always flows downstream. You will see the cause and effect of different elevations. For example, water will flow slowly between Lake Michigan and Lake Huron because they are similar in elevation. However, water will flow quickly from Lake Erie to Lake Ontario because of the large height difference. The elevation change is known as the Niagara Falls. Our model is roughly to scale and proportion. You will see that the rivers are different lengths and connect the lakes together. Stability and change is shown through repeated paths of water and the effects from pollution. During this model, you will see how pollution in one lake can affect the other lakes and the ocean. Lastly, systems and system models are used throughout the creation and observation of this working model.
All of the water starts in Lake Superior, which is the largest, deepest, and highest elevated of all of the Great Lakes. From Lake Superior, the water flows down to Lake Huron, and through the Straits of Mackinac, it flows from Lake Huron to Lake Michigan, which is at the same elevation. From Lake Huron, water flows down to Lake St. Clair, which is smaller and slightly lower in elevation than Lake Huron in Michigan. From Lake St. Clair, the water goes down to even lower elevation, but just slightly lower, to Lake Erie. Between Lake Erie and Lake Ontario is Niagara Falls, which is a very short, very steep river and waterfall. From Lake Ontario, the water goes to the ocean. It should be noted, however, that in our model, there were no leaks between the rivers and the lakes. But if that were to happen, that would represent flooding and groundwater.
The water flow begins in Lake Superior. Lake Superior is the deepest and largest and highest in elevation of all the Great Lakes. From Lake Superior, the water will flow into Lake Huron, which is just a bit lower in elevation. From Lake Huron, the water flows into Lake Michigan. Also from Lake Huron, the water will flow into Lake St. Clair. From Lake St. Clair, the water flows into Lake Erie. Notice how we have some pollution in Lake Erie. The pollution is going to continue with the water's path. From Lake Erie, the pollution in water will continue into Lake Ontario. From Lake Ontario, the pollution in water will continue through the St. Lawrence River into the Atlantic Ocean.
This time, the pollution starts in Lake Superior, which is the northernmost and deepest of the Great Lakes. From Lake Superior, the polluted water spreads to Lake Huron. The polluted water then starts to spread to Lake Michigan and the St. Clair River. Notice that the polluted water becomes less concentrated as it travels farther. This indicates that pollution decreases in concentration as it spreads throughout space. Once Lake Michigan and the St. Clair River are full, the polluted water spreads to Lake Erie. After some time, the polluted water then spreads to Lake Ontario. After it reaches Lake Ontario, the water flows to the Atlantic Ocean via a river. Since the water that is flowing to the Atlantic Ocean is still polluted, the Atlantic Ocean will then become contaminated as well.